Hi, now I'm gonna continue my elaboration tree, and we're gonna continue the pseudocode and the square root. So what I'm gonna do here is I'm gonna make a equals to 4, and then I will have n equals to 0, and then I will have x equals to linspace. In parentheses 0, the a, and I want 7 numbers between 0 and a. So what the linspace function simply do is that linspace in parentheses, you write the first two numbers or digits like variables, and then you will write the number. After the last comma, you will write the number. That means that how many numbers you want between the first number and the second number or variable. So in this case, I have a 0 and an a, which is 4. So it will give me 7 numbers between 0 and 4. So then I will make y equals to the numbers I have between 0 and 4, but I will not have it as 7 here. I will have it as 0, 1, 2, 3, 4. So I have it as a 5 here, because 0, 1, 2, 3, 4 is 5 numbers there. So the y, it will be zeros inside brackets, and as we can see in the task here, the yn is y divided equals to 1 divided by a times xn powered to 2. So what I simply do here is I put the y equals to, in brackets, 5 zeros, because it's 5 numbers between 0 and 4. So the next thing I will do here is to display the x. I'll display the x here, because that's what the task says. I'm going to display the x, and then I'm going to repeat with all the 5 numbers. So that's why I put 5 zeros in the y, and I'll put epsilon equals to 1000, and then I will have, for n equals to 1, and then I will have yn which equals to, from the task, 1 divided by a times xn powered up to 2. So that's what we will do. That's what I will do here, divided by a times xn powered up to 2, and then we will put x n plus 1 equals to x n divided by 8 times all this in the parentheses, 15 minus yn times 10 minus 3 yn. So that's what I will write it right here. X n plus 1 equals to x n divided by 8. Oh, sorry. I need to put this with xn divided by 8 times and I'll put them here in parentheses because so it don't give me the wrong value in the end in the comment window. So 15 minus yn and it's times in parentheses 10 minus 3 times 10 minus 3 times yn. 10 minus 3 times y and in the parentheses n and then and then we have that you can see in the task n equals to n plus 1. So then we have another value for n. I'm gonna have a second, oh yeah, there will be another value for n. N equals to n plus 1. Sorry, I'll put this there's some space here. And then we have the if that should be here. The if command for absolute so I have it here. X n plus 1 minus xn is less than epsilon. So what we're gonna have here is the as we saw in the task x n plus 1 for n plus 1 sorry, I will skip the space here. Xn plus 1 minus xn, I saw in the task, and then we close the parentheses here, is less than epsilon, which I put it as 1000. So under here we will display the numbers that are like the numbers for condition is met. So this function, what it simply does is that it's displaying the numbers for what I write in here. So I write condition is met for this row here. If this is less than epsilon, then the condition is met. If x n plus 1 minus x for n is less than epsilon, then the condition is met. So, and we will also, let's say in the task, we will display x and the square root of a and the n. So I will also display the x of n, the x of n, and then I will display the square root of a square root of a, and I will also display the n. Display the n. And after this display, I will end it, and then I will display also condition is not met, so it will bring me in the command window also the numbers for which the condition is not met. So condition is not met. Is not met. So so now we will run and see what this will give us. It will give us so when we run it, it gave us you can see here, it gave us the a value, the n value, which is 0 equals to 4, and a equals to 4, and then we have the x in the linspace, that's 5 numbers, 5 digits from 0 to 4, and the y matrix and we have the epsilon, which is 1000, and the yn, and the different numbers for x, and the n, which is the n equals to n plus 1. And here we can see that the condition is met. We have 0, which is the display for xn, the 2 display of the square root of a, square root of 4, which is 2, and display of n, which is n equals to n plus 1, which is 2. Yes, so x here, 3, 4. So for the x n plus 1, the value here that we get from the x n plus 1, that's the values that we get from x n plus 1. 0, 0, 2, 3, 4. And then we have the value for n, and the condition is met and the condition is not met. So yes, so now we go to the next task, which is the Maclaurin. So I'll create a new script here. So we have I will call it migration 3 McLaurin. And I will have one percentage sign for big X that I will use equals to linspace so we will see what we'll have here in linspace. So we want a value with we want a table with 10 values between 0 and pi divided by 2. So to do that, we're going to put in the linspace 0 pi divided by 2 and 10. And then I'll simply write this one more time, because so the command window, take it in linspace 0 pi divided by 2 and 10. So here we have, that means we have 10 numbers between 0 to p divided by 2. And after that we will have Mac, which is I use Mac as a shorter word for Maclaurin, equals to only brackets here, which I will define later, and for k equals to 1 to 10, and then Mac in parentheses Maclaurin, which is the Maclaurin, colon, comma k, colon, comma k equals to -1 dot powered up to what is it here that we have? So the Maclaurin series approximate cosx is cosx, yes, and it can be also written as this. So that's what I'm implementing in now in the script in MATLAB. Powered up to k minus 1, and close this one, and that times x powered up to k minus 1 times 2. This is x powered up to k minus 1, and then close this one, times 2 times 2. And then we will divide that by factoriate, which is in English factorial. Factoriate k minus 1 times 2. So times 2 close the parentheses, divided by, in parentheses, factorial, in parentheses, k minus 1, close the parentheses, times 2 so gives us an error here, maybe like that, yes, it's really better. And then that's the end of for this one. And then we're going to implement this function stop when first either of the following criteria is met. So here I have I only use the criteria for k equals to 10 because I have k equals to 1, between 1 and 10, all the numbers between 1 and 10. This we have, I put that for k. So so what I will do now is the sum for Mac, which is equals to, in parentheses, sum, in parentheses, Mac, comma, 2, and what I'm going to do is I'm going to build a table with 10 values between 0 and pi divided by 2 to be shown in one column, and each value to be represented with 3 values in the equivalent row. The angle, the result for code for this angle, from my code for this angle, and the result of the cos function of MATLAB, as the below figure shows. So to define the sum Mac, sum of the Maclaurin function, that's the command I need to use, sum Mac, comma 2, and then to define the angles I need to use this function, rad2 dec, and in parentheses, because in this case the value is the same as the x, so I will call it for x instead of values. So now I've defined the sum of Maclaurin and the angles. So what I'm going to build here is a table now, the table of x, the angles, and the a. The a and, oh, sorry for that. The Mac x. So I'm gonna define cosinus x with a variable. So I put it as a equals to cosinus of x, and then I'll create the table T1, which is equals to table sorry for that. So now I'll transpose these values, which is exactly the same thing as just writing the values inside the parentheses for table, inside the parentheses for the table function. So transpose of x, and then we'll transpose the angles as well. Transpose angles, and I will transpose the A, and the summec. Don't need to write transpose. So I just wrote summec here, just because. So what you can see here is that there is an error table. Might be missing a closing. Was it invalid syntax at end of the line? Yes. So now that should be fine, I think. What's the problem here? Might be missing a closing. Yes. So now it's done. So I think everything is done. I've created the table as well, so we're gonna run it and see what we get as an output. So we forgot the parentheses over there. So as we can see here, I got the results in the comment window. So we're gonna see what the result gave us. So here we have the values of x, which is 10 values between 0 and pi divided by 2. And then I have the mac, which I also only put brackets in the beginning. And then we have the Maclaurin for and then we have the different values for the function of Maclaurin. -1 powered up to k minus 1 times x powered up to k minus 1 times 2 divided by factorial k minus 1 times 2. So is this values mac, you can see because we have 10 different values for k, so that's why it brings the values for each k that we use for each time, like from 1 to 10. And then we have the values of some mac, which is 10 numbers from 0 and up to 1, or from 1 down to 0, and it goes less and less for each step. And then we have the row for the angles with 10 columns, the row for the A, for the cos. So this is what it transposed the sum make, the angles, the A and the X values. The value for the Maclaurin. In the end we got the table as it said in the task that they want each value to be represented with 3 values in the equivalent row, which is the angle, the result from your code for this angle, the result for the cos function of MATLAB. So as you can see, we have a 10 times 4 table, 10 by 4 table, and the first column gives us the x values from 0 to p divided by 2, 10 values there, and the second gives us the angles, values of the angles from 0 to 90, and the third gives us the a values, which is 1 to 6.1232 times 10 powered up to minus 17, and then the last column gives us the summate 10 different values for summate between 1 and minus 3.3769 times 10 powered up to minus 15. So that's it. Thank you.